Hello students, let me explain the damped vibrations now. So in our daily experience, whenever we see the vibrations of a body, okay, we see that after sometimes the amplitude of vibration starts decreasing. Finally the body stops. Okay, so this kind of vibrations are called damped vibrations. So the periodic vibrations of a body of decreasing amplitude in presence of a resistive force are called damped vibrations. So the vibrations is periodic only, it vibrates to and fro. So periodic vibrations of a body with decreasing amplitude. Okay, amplitude is decreasing continuously due to the resistive force are called damped vibrations. So in damped vibrations there are two forces acting. One is called the restoring force, which is actually causing the body to vibrate. Another is the frictional force or the resistive force. Why do you call it resistive force? Because the force, this frictional force, actually resists the motion of vibrations of the body, and this frictional force is provided by surrounding medium. Okay, so amplitude of motion decreases due to the friction force. So friction force at any instant is proportional to the velocity. Now frictional force can be measured. It depends upon the velocity of vibration. More is the velocity of vibration of the body, more will be the frictional force. Okay, and it has tendency to resist motion as we know it. Okay, so because of the frictional force, the vibrating body has to do work against the force of friction. Okay, so whenever it does work against the force of friction, the energy is lost, energy is dissipated in doing work, and that energy is given to the surrounding in the form of heat. Okay, so as long as the body has energy, it vibrates, but when the energy of the body is completely lost, stops vibrating. Okay, therefore as the body vibrates, the energy is lost gradually, and hence the amplitude vibration also decreases. Okay, so once the energy is completely lost, the amplitude vibration also becomes zero and the body stops vibrating. So the rate at which the energy is lost to the surrounding, or the rate of decrease of amplitude, depends upon two things. It depends upon the nature of the medium, and also depends upon the nature of the vibrating body, or shape and size of the vibrating body, and it depends upon the nature of the medium. So when we say nature, it means viscosity of the medium and density of the medium. So depending upon different viscosity and density of the medium, uh, the body the rate of dissipation of energy in a medium depends. Understood? Okay, this is a displacement versus time graph for the damped vibration. As you can see, initially when t equals to 0, initially the amplitude of vibration is large, but as the time proceeds, as we go towards the time axis, as the time elapses, the amplitude of vibration starts decreasing, and finally it becomes 0. Okay, so this is a displacement versus time graph for damped vibrations. What are the examples of damped vibrations? When a slim branch of a tree is pulled and it is released, then it makes vibrations. So the vibrations made by this kind of branch is called damped vibrations, because initially the amplitude of vibration is large, but as the time continues, the amplitude of vibration starts decreasing, and finally it stops. Other examples are the tuning fork when we strike it on rubber pad, and simple pendulum oscillating in air also executes damped vibrations. Okay, so these are the examples of damped vibrations.